Hello everyone, welcome back to the course Vector Calculus and Complex Analysis. Myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology. And coming to the overview of today's presentation. Today I am going to express the given function as a Laurent series. Some f of z will be given and in some region. For example, mod z less than 1 or mod less than 2 and so on. So, we express the given function as a Laurent series. So, the problems on Laurent series. In the last class also we discussed about the same. We have solved some problems on Laurent series expansion. Now, today I am going to solve some more problems on the same topic. And here a series of expansion f of z in non-negative powers of z minus a is possible using these expansions. In powers of z minus a, that means about a point z equal to a. Some of those series are Taylor series, Maclaurin series and Laurent series. And here the question is, can we think of having a power series expansion around z equal to a, around z minus a, even if z equal to a is a singular point of the function f of z. So, can we think of a power series expansion around z minus a even z equal to a is a singular point? Yes, it is possible using Laurent series expansion. Now, coming to the first problem, expand f of z in the region. So, the first region is 0 less than mod z minus 1 less than 1 and the second 1 less than mod z less than 2. Now, what is the given function? Given f of z is 1 by z square minus 3z plus 2. So, the denominator is a quadratic polynomial in z. So, we can find the factors of this. This can be written as 1 by z minus 1 and z minus 2. So, the product of these two factors z square minus 3z plus 2. And now, let us simplify this first. So, here this can be written as z minus 1 minus z minus 2 by z minus 1 into z minus 2. If I write like this, z minus z cancel, minus 1 minus of minus 2 which is plus 2, so plus 1. Hence, this expression can be represented in this form. Now, by simplifying a minus b by c form, so z minus 1 by z minus 1 into this, so that becomes 1 by z minus 2 minus these two cancel in the second term 1 by z minus 1. And now, the first question, in the first question the region is mod z minus 1, 0 less than mod z minus 1 less than 1. If it is directly given in the form of mod z, that means a circle with center at origin, we can directly solve the problem, but we can expand it using the known expansions. Whereas here z minus 1 is there, so put z minus 1 equal to w. That implies z is w plus 1. Then f of z becomes 1 by z minus 2, w plus 1 minus 2 minus 1 by z minus 1 which is w. So, this is minus 1 by w plus 1 by w minus 1. So, I will write this as minus of 1 by 1 minus w. Since here this z minus 1 is less than 1, so I have written in this form 1 minus w. So, f of z is equal to minus 1 by w minus, this is 1 by 1 minus w can be written as power minus 1 minus 1 by w minus 1 minus w minus 1. Using the known expansion, this is 1 plus w square plus w cube plus so on. Now, then replace this w by z minus 1. Then f of z becomes minus 1 by z minus 1 minus of 1 plus z minus 1 plus z minus 1 whole square plus so on. So, this is the expansion which is valid in the given region. Similarly, we can expand in the second region, in the second bit, 1 less than mod less mod z less than 2. So here 1 less than mod z, that implies mod z is greater than 1. So mod 1 by z is less than 1. This is one point. And then mod z is less than 2. So mod z by 2 is less than 1. So we try to express the given, or we try to get these terms 1 by z and z by 2 while simplifying the function f of z. Now what is the given function f of z? 1 by z minus 2 minus 1 by z minus 1. So here I should get z by 2 term. So minus 2 I will take common, then 1 minus z by 2. Yeah, here we have that term minus, and I need 1 by z. So 1 by z common, 1 minus 1 by z. Now we can simplify this, minus 1 by 2 into 1 minus z by 2 power minus 1 minus 1 by z into power minus 1. So this is minus 1 by 2 using the known expansions, 1 plus z by 2 plus z square by 4 plus so on, minus 1 by, this is z and this is 2, 1 plus 1 by z plus 1 by z square plus so on. So this is the required expansion of the given function in the given region. We are coming to the second problem. F of z is z minus 1 by z. In the region mod z minus 1 is greater than 1. So let us consider this z minus 1 as w. So z is w plus 1. Then f of z becomes z minus 1 is w by z is w plus 1. So I will take this w common here, 1 plus 1 by w, these two gets cancelled, and 1 plus 1 by w whole power minus 1, which is 1 minus plus minus and so on. Here plus, the sign changes alternately, since here we have plus sign and here the minus sign. Hence the given function f of z, z minus 1 by z can be written in the form 1 minus 1 by w is z minus 1, z minus 1 whole square, z minus 1 whole cube plus so on, which is valid in the given region z minus 1 greater than 1. So that means 1 by z minus 1 is less than 1. So we have those terms here. Now the third one, expand f of z equal to z square minus 6z minus 1 by z minus 1 into z minus 3 into z plus 2 as a Laurent series in the region 3 less than mod z plus 3 less than 5. So the given function f of z is z square minus 6z minus 1 by z minus 1 into z minus 3 into z plus 2. So by resolving into partial fractions, we get this is equal to 1 by z minus 1 minus 1 by z minus 3 plus 1 by z plus 2. This you can practice, and you know how to find the partial fractions. Since we have the factors in the denominator, a by z minus 1 plus b by z minus 3 plus c by z plus 2, and by finding the values of a, b, c, you can get these partial fractions. Now the given region is 3 less than mod z plus 3 less than 5. Now try to get this z plus 3 term here. So therefore the function f of z becomes 1 by, here we have z plus 3, try to get the same term here, z plus 3 minus 4, so that it becomes z minus 1 minus 1 by z plus 3 minus 6 plus 1 by z plus 3 minus 1, so that z plus 3 minus 1 is z plus 2. Now we can simplify this by taking this z plus 3 common. So 1 minus 4 by z plus 3 minus 1 by, here I can take this 6 common, plus 1 by 6, 1 by 1 minus z plus 3 by 6 plus 1 by z plus 3 common, 1 minus 1 by z plus 3. So, using the known expansions, we can expand this f of z equal to 1 by z plus 3 whole into 1 minus 4 by z plus 3 power minus 1 plus 1 by 6 into 1 minus z plus 3 by 6 power minus 1 plus 1 by z plus 3 into 1 minus 1 by z plus 3. So, by expanding these functions, we get 1 plus 4 by z plus 3 plus 16 by z plus 3 whole square plus so on, plus 1 by 6 into 1 plus z plus 3 by 6, z plus 3 whole square by 36 and so on, plus 1 by z plus 3 into 1 plus 1 by z plus 3 plus z plus 3 whole square plus so on. So, in today's session, for the given f of z in the given region, we have expressed this f of x as a Laurent series expansion. So, in the next session, again we solve some more problems on the same topic. So, this is for today's session. We will meet in the next session. Thank you.